True or false? The law of reflection is only true for light waves. Of course not. It can work for any kind of wave, right? Radio waves, water waves, sound waves, etc. True or false? The law of reflection only applies to smooth surfaces. That's also false. So like a piece of paper, of course light reflects off a piece of paper, but you can't like look at a piece of paper and like comb your hair. Piece of paper is rough, so you get a diffuse reflection. The light scatters. You need a very smooth surface to get a specular reflection. Okay, next, let's just practice drawing a reflected ray really quick. We're going to use a protractor and a ruler. So the first thing is this incoming light ray. Let's label that with the vocabulary term. This is called your, what's the fancy word? Your incident ray. Incident ray. You reference all angles from this imaginary perpendicular line. What are you going to call that? You guys remember? That's called the normal, a geometric term for perpendicular to a surface. This is obviously the mirror surface, okay? So what I want to point out is what's tricky is all light rays are not referenced from like a mirror itself, the surface of the mirror, but from an imaginary perpendicular line. And the reason why is if you curve the mirror, then you have a way to reference that angle, because you can always draw on the tangent to a curved surface. Otherwise, how do you measure an angle from a curved surface? So now that we have our normal line, our incident ray, we can measure with our protractor our incident angle right in here. This is my angle of incidence. So I'm going to get out my protractor, line it up with this line, and one little problem with a lot of protractors is they're not quite big enough, or small enough rather, so you have to extend the line a little bit longer so your protractor will actually get a reading for you. So I'm going to go ahead and line that up. Well, question, right? Do I want to read it from the normal line or from the surface of the mirror? What's the right way to do that? All rays are referenced from the normal line. That's correct. So it's looking like not quite 60 degrees, a little bit shy of that, right? 56 degrees. So if my angle of incidence is 56 degrees, what's my angle of reflection going to be? Also what? Should be 56 degrees. So I'll measure out 56 on the other side with my protractor. Then I'll take my ruler and line it up with my 56 degrees. Then we'll draw in our reflected ray there with our ruler. And then this angle should be equal to this angle there, right? That's my angle of reflection. Here we have a few more for you to practice here. And all it is we just apply the law of reflection. So how do you know how the ray is going to bounce? It doesn't bounce randomly. If you shoot a pool ball, this is a pool ball, at a bumper on a pool table, what does a good pool player know is going to happen? Any angle that you come in at is going to be the angle that you leave at. So first I draw on my normal line. What does normal mean? It means perpendicular, right? Yeah, this is my 90-degree angle right here. And what do I know about my incident angle compared to my reflected angle? So whatever angle I come in at should be the same as the angle that I leave at there. Which one's a little bit trickier here? Can you tell? Which one? Yeah, D's tricky. Why is D tricky? Because I'm hitting a what? Curved surface. That's correct. So how can light bounce off a curved surface? Can light bounce off a curved mirror? So on a curved mirror, how do you figure it out? It's real easy. When the ray of light hits it, at that single point, it acts as if the mirror was flat. So what you got to do is you have to draw on what's called a tangent line. What does tangent mean? It only touches the curve at how many points? At 1 point, right? So draw on your tangent. How do we reference all rays of light from a mirrored surface? What's that imaginary perpendicular line called? It's called the normal line. So perpendicular to the tangent line, there's my perpendicular. This is my normal right here. I can reference then my angle of incidence from my angle of reflection. Instead of using the protractor, let's just use our human eye here for symmetry because it's close enough. Now, of course, if we were going to build an optical instrument, we would want to measure precisely with a protractor. But on this worksheet, the human eye is probably just as good. So what's the difference between a specular and diffuse reflection? Specular is just a fancy word for smooth surface, smooth reflections. So which surfaces are smooth? A, B, C, D, right? And then which one would give me a diffuse reflection? Diffuse is just a fancy word for a rough surface. So which surface is bumpy and uneven? Obviously, right? It'd be surface E there.